Stanford University.
Okay, well, welcome to lecture number 11, I believe, of Stanford CS 193P, winter 2015. And today we have a few topics to talk about. I'm going to start off by talking to you about your final project requirements, you know, all the details of what you need to do and by when. Then we're going to go over some topics briefly. I'll get through as many of these as I can fit the time of. I might not, especially the last one, probably won't get to, but that's okay. I'll just start off the lecture next week because we don't have a lecture on Monday, so next Wednesday will be our next lecture. All right, so let's dive right into these final project requirements, and feel free to stop and ask me questions if I say something you don't understand it. We ask everyone to submit a proposal for what they're going to do. And it's a simple proposal. I'm going to kind of show you a sample proposal in a minute or two so you can get an idea of what a proposal looks like. Proposals, please submit them in PDF format only, not just sending them in an email or in Word format or something like that. Please, PDF. And the proposal really is going to have two big sections in it. One is what you're doing, obviously, and then another one is what parts of iOS you're going to use. Okay, and again, I'm going to show you a sample of that in a second. The project is going to be due on Friday the 13th. Dun, dun, dun. So be ready for that. Midnight on that day, Pacific time, yes. Use the normal submission process. There'll be an option in there for the final project. You can't use any free late days. We're already totally pushing this out to as late as we can and still get them all graded and by the time we have to get the grade submitted. So lateness is very highly penalized, basically 1 letter grade per day because we just can't afford it to be late. Okay, so if you're going to use, if you have any free late days left, use them on assignments 4 and 5 because you cannot use them on the final project. I can't grant extensions. There's just really no time for extensions. So basically submit whatever you have on Friday the 13th and see what happens. You can, if you don't like Friday the 13th, you can submit it on the 12th. That'd be fine. This is a 3-week-long project, right? It's not due until basically, what, 4.5 weeks from today, but you need a week to think about what you're going to do. And you still have a couple assignments left. So it's just basically a 3-week-long project. So even a last-minute emergency shouldn't hurt you too bad. Okay, so plan accordingly. Start early and try to get it done early. That way, if you have problems, also you have plenty of times to go track things down. If you don't start until the last week of the 3-week project, your project's not going to turn out that good. I can pretty much guarantee that. People often ask, can we work in teams on this final project? And the answer is generally no. But I do allow teams of 2 only in these very specific circumstances here. Both students have to be taking the course pass no credit. The homework grades for both students have to be substantially similar and good. Okay, so if anyone, no team can consist of anyone who's basically been struggling in the course so far. You have to submit a proposal, and your proposal has to be explicitly approved. The rest of you are going to submit a proposal, and we're going to give you feedback on it, but there's no process whereby we have to say, yes, this is approved, now go forward. You're just going to get feedback. But if you're doing the team of 2, you do have to get it explicitly approved. And of course, that proposal would have to cover 6 weeks of homework time worth of work because there's 2 of you. Okay, so that's twice as much in there. So the proposal also not only is going to have to show the things that I'm going to talk about later, but it also has to include who's going to do what. And I really strongly encourage you to break up the work that's going to be happening between 2 people along class boundaries. So this class is being written by Joe, and this class is being written by Jane. Okay, so it's very clear who's doing what, as opposed to, oh, we work together on this, and then it's hard for us to tell, well, who actually understands what in here. Okay? Then when you submit your code, you have to follow that up with a clear delineation. This person did this person did that. And again, hopefully that's this class was written by this person, this class was written by that person. Okay, so we don't end up with very many teams of 2 every quarter because of these strict requirements, but if you want to try and give it a try, you want to submit your proposal as soon as you can put it together, like in the next couple days, and start getting your grader to give you feedback on it as soon as possible so you can iterate and make sure that you have something that's workable. Okay? Otherwise, I strongly recommend kind of individual work. I mean, this course is about learning to be an iOS developer, and if you want us to be able to measure your success at that learning process, it's individual work, okay? Now, understand that when you go out into the real world, programming is never individual work. It's almost, I mean, 5% of what's going on in the world programming-wise is some individual work, okay? It's 95% you're working in teams. And I wish I had more than 10 weeks so we could work on working in teams. But we just don't have time for that, unfortunately. All right. You'll be graded basically on your proper use of the iOS SDK, so don't hack, okay? Make sure you understand, you read the documentation of the classes you're using and you use them properly. The other thing I'm going to say is that breadth is very, very important. Breadth meaning show me as much of the iOS API as you can, okay? Rather than going really, really deep and doing one thing really, really, really well. Some people are, you know, graphics whizzes and they go do these incredible graphics apps, and I say to them, well, if this had been a graphics course, you'd have gotten an A+. But unfortunately, it's an iOS development course, and you didn't show me much iOS. You just showed me only the graphics part. I don't know whether you can do table views and all these other things. What's going on? So breadth is extremely important. This is probably the most important. And then the second thing is we're going to ask you to do one significant feature that I did not teach in lecture. And that's because being an iOS is huge. I only teach the tiniest little fraction of it. I really just teach things that teach you the concepts you need to learn other things in iOS. So you really need to show that you can go to the documentation, go on the internet, figure out how to do something substantial in iOS without me basically showing you and giving you a demo of it, etc. So those, I put them in yellow there because those are really the two most important things to get right. You don't want to get stuck down a rat hole, like I'm saying here, where you just spend 2 of your 3 weeks kind of chasing after one thing that never really pans out, and now you only have a week left to do a lot of breadth. So if you start doing something and you're just like, God, I completely don't understand this, or I can't figure it out, just cut and run. Go pick something else, some other feature to put in your application instead. Notice that I don't say anything here that you're going to be graded on how cool your app is, or how ready for the App Store it is, or how much money it's going to make. Okay, none of those things are part of the requirements. This is an academic course. You're trying to show me your iOS capabilities. That's the #1 requirement. Okay. Now, if after this course you want to then take some features out, maybe, that you threw in just to show me that you knew how to do something in iOS, or if you want to add some features because there was something too complicated to do in theory, hey, that more power to you. Many, many final projects have eventually ended up on the App Store, but that is nothing to do with the requirements, not even, you know, mentioned as part of what you're supposed to do. Okay, I don't even care about that. Okay, the scope of the project, like how much work it is, it should be 3 weeks of homework worth of work, especially 3 of the last weeks of homework, because you're supposed to know iOS by the end of this quarter. So if you take the combination of assignment 3, 4, and 5, which is the graphing calculator, and then the smash tag that you're working on now, and there's going to be an animation-based thing. If you take that much worth of homework work, that's about how much your final project should be. Okay, maybe even slightly more, because some of the stuff that you're going to put in your final project, yeah, you already know how you already did it in the assignment, so it should be easy peasy for you. Okay. Just a reminder that everyone, pass no credit or letter grade, you have to pass both the homework and the final project separately. At Stanford, a passing grade is a C- or better. Okay. So we will tell you if you have not passed the homework portion once we finish grading homework assignment 5. Okay. So then you can just stop work on the final project at that point. All right. Well, you can keep working on it if you want, but you're not going to pass the course if you don't pass that part. Okay? Okay, questions about the scope? Scope is important. It's one of the things that people fall down on. They basically submit something that's kind of 2 weeks worth of work. And so 2 weeks of work, that's 2/3 of the total points. That's not a very good grade. So you want to make sure you get your scope right there. Do not just regurgitate your homework assignments, okay? I do not want to see smash tag 2, okay? And every quarter, it seems like I always get a handful of people who, they can't really think of something to do, so they basically just take smash tag, or maybe the last homework assignment, and they just kind of change the names, and, you know, it's very, very similar. Don't do that, okay? because then you'll have just shown us that what you've already shown us, which is you know how to do the homework. Okay, great, we already know know how to do the homework. Now show us different. Basically, one thing to think about is you want to start your final project from scratch. You don't want to start it with smash tag and then start changing it, or with assignment 5 and then start changing it, or with the calculator and just start changing it. Start from scratch. Okay, that will help emphasize that you don't want to just turn in a regurgitation of the homework assignment. And in fact, whatever you do in your final project, try to do things a little differently than we did them in the assignments. Because if you do something exactly the same way we did it in the assignment, like if you had a table view and its data structure is exactly the way we did it for the assignment, it's kind of like, well, we already knew they could do that. So don't do that, okay? Pick a different data structure, something more interesting. Do a couple more features in table view, okay? Do things like that maybe are extra credit in the homework. Do those in your final project, those kind of things to get some difference between your homework, yeah.
Different, or what's like a hack? Like if I make my primary data structure like a linked list, for example, is that like a hack, or is that?
Okay, so the question is, how do I know if I do something different than what was talked about in lecture if I'm not now doing hackery, okay? And the answer is, well, you're going to have to figure that out, because when you go out into the real world and build iOS apps, you need to not be a hacker. And the way you figure those things out is by reading the documentation. If you read the documentation of a method and it says this method works this way and you use it that way, then you're not hacking. Okay? If you go out on the internet and it says, oh, you can call this private method with this thing and it'll work, then now you're starting to hack, right? Or if you just don't read the documentation and just start typing things in until they work, okay? I used to have a great GIF, I don't have it now, where it's just this GIF of this guy just banging on the keyboard and then banging his head until he's just a bloody mess. And that's a programming approach that, doesn't scale very well. So, you'll know if you're hacking. It'll be clear. You can always ask your TAs. There'll still be office hours all for the rest of the quarter. You can, go find out if you're hacking. All right, so some examples of bad projects. We already talked about Smash Tag 2. That's a bad project. Another bad project is one that has very little breadth. Like it's lots of MVCs being segued to each other, but all the MVCs are basically the same. A bunch of buttons and text fields and labels, and that's it. There's no table views in there. There's no animation. There's no custom view with draw rect. You see what I'm saying? It's all just the same thing over and over. Or vice versa with the table views. It's table view after table view after table view after table view, and there's nothing else, just table views. That's all, isn't it? The whole app is table views. Those are bad apps. An animated game, like you're doing a game that's all a video game where a guy running around and shooting bullets and all that stuff, that's bad too, because where's the table views? It shows me that you know the animation stuff, great, but I need to see all the rest, text fields and labels and segues and all that. Where's that if it's just this one screen where the guy's running around jumping, okay? Another one is some cool mathematical thing or an image filter that uses your PhD research to calculate something. That's great that you worked your PhD research in there, except for if that's 90% or 80% of what you did, then you're going to get an F in this class because only 20% is going to be iOS stuff. You want it to be the other way around, 90% iOS, and if you want to spend 10% of your time on putting your PhD stuff in there or some network resource or whatever, that's fine. The aesthetics of your UI do matter. Okay, we don't want these junky, totally crappy looking things, but I don't expect you to be graphic designers, you're programmers. So that just basically means, do your auto layout nicely, line things up. The dash blue lines help you line things up so things should look nice. Also, don't be afraid to go out on the internet, find some nice icon or something to do in there. You're really not even going to have to worry about, do I have the rights to use this icon? Because it's only for your personal work. You're not going to be shipping it on the App Store. If you do ship in the App Store, you have to change your icons or either buy them or use stuff that's free to use, all that. But for this, you don't have to worry about that. So we do want to see it. By the same token, this is not a computer-human interface class, okay? So that's not going to be a primary thing. I just want you to make sure you don't turn in a bunch of junk. Okay? You wouldn't want that either. Your final project has to work on hardware, okay? And you have to demonstrate that to us. So you're going to have a final presentation, which I'm going to talk about in a second. And if you do a live demo on hardware, then you've satisfied that requirement. If you don't, then you need to show your TA. Usually they'll hang around after the final presentation slot, or you could show it to them anytime before that in office hours or whatever. Show them your app working. So that's an important part. You can't just be simulator only. And you're going to notice that assignment, I don't know if I made assignment 4 be hardware required. I guess not, but assignment 5 will definitely be this must work on hardware. Okay? Yeah, this is kind of a reiteration of what I said before, but don't get sidetracked on non-iOS code. If you have something like a database that you're going to use or a login, a lot of people want to do a social networking app, which is great, and you have to have a login or something like that. You know, you can fake it, fake the login. Just have 3 users, and that's all, right? And it's some, as long as you do it in a nice object-oriented way, where that faked backend is its own object somewhere or whatever. That's the way you want to do it, because again, you want to focus all your time on showing me as much iOS usage as you can cram in there. Okay, so if you waste a week hooking up to a network server, you've wasted a week. Okay, now you got to cram 3 weeks of iOS programming code into 2 weeks, so don't do that. Okay, so be careful there. All right, presentation. This presentation I mentioned. So there's so many of you this quarter. This is the max we've ever had. Normally we have a 2-minute presentation where you get up here for 2 minutes and you have to just basically tell us all about your app. I call it sometimes the venture capitalist pitch. Imagine you have venture capitalists here and you're trying to get them to invest in your company to build this app. You want to put your app in the best light and show it off, and you want to show off all aspects of it. So give us screenshots, do a live demo if you dare. You can see I do live demos and they can be perilous. But somehow, you know, pitch your app to us. So unfortunately, we only get 90 seconds because there's so many of you. We only get a 3-hour slot, and I didn't really want to spill over too much into the alternate final slot. So 90 seconds, that doesn't seem like a long time, but actually you can say a lot in 90 seconds. Okay? If you're very focused on what you have to say, you can show basically your entire UI in about 30 seconds. Yeah, so I think I say on here, maybe I get to a second. The question is, can I just make a video and get up here and press play? And the answer is no. Okay? I want you guys to have the experience of standing up in front of your peers and having to talk to them. That's a very, very important skill in your life. Okay? And so you need to do that. So no pressing play. Okay? I need your slides before, because I'm going to put all the slides in one big thing so we can race through this. Okay? We got to get through 100 people, 90 seconds each, with like 10 seconds in between. We're going to have to be really racing through. So you're going to give me all your slides. I'm going to put them all in one gigantic presentation, and we're just going to be clicking through the slides, person after person. We won't have any switching time. Please make your slides, if you haven't noticed by now, widescreen. Okay, 1280 by 720. Do not send me 1024 760 or 800 by 600 slides. They will look funny. Okay. The slides are due to me the day after your final project is due, so you can get your final project in and then spend the next day if you want to, craft your presentation, do some screenshots or whatever. Whatever you present, though, in terms of slides or UI on that second day should be what you turned in. So don't spend Saturday adding more graphics and all that stuff and then putting up slides that are not what your app is. Okay, your app, the presentation you give has to be the app you turned in. Make sense? You submit the slides also using a normal process. There'll be a different submit target for that. Final project slides, it'll be called. So yes, that's the way you do that. Now, I know some of you have a conflict with the final exam, although I don't really know how that's supposed to happen because all the final exams are supposed to not conflict with each other, but I know you guys have other things. You're the GSB or something else. So I am going to have an alternate final slot, if you want, which is the very last lecture of this course. So you can do your presentation then if you prefer. And there will be a sign up for that, but it'll be really easy. I'll announce it on Piazza a couple weeks before. Okay? If you do the alternate time, obviously I need your slides sooner. So I need them by the Monday before, actually. Now, in that case, you still get to turn your stuff in by the Friday, so you're going to have to be making your presentation out of your app's not done yet, maybe. But you just got to do the best you can if you want to go early. Okay? But presenting early has no effect on when the actual thing is due. You're still due on Friday the 13th. Okay? The quality of your presentation, people say, oh, does it matter? Yes, of course it matters. Okay? It matters for you and your experience here at Stanford to be giving good presentations. Does it matter to your final grade? Oh yeah, a tiny little bit. If you come up here and you totally bomb, you do a live demo and it's a complete mess, we're not going to go, oh, that's a B for that guy. No, but still, we want, you can kind of impress us. If you come up and do a really great demo and it really shows up your app well, we're more likely to walk away going, wow, that was a little better app than I thought. Okay, but if you come up here and you're terrible, then we might be like, which app was that? I thought that was a terrible app. Okay, so it matters a little because it gives us an impression. So, and that 90 seconds, is going to be strictly enforced. I'm literally going to say, okay, thank you, right at 90 seconds, because we just cannot afford to go over too many people. Oh yeah, question, should I do a live demo? I love live demos, as you can tell. I do a live demo almost every single lecture. But I know that for some people, it's like, oh, it's a little scary, it might not work, especially if you're going out on the network. Maybe you can't get the network or something, so it's dangerous. So what I recommend is, live demos are pretty effective. So, you know, try and put a live demo together if you can, but have a backup. If you get up here to do your live demo, it's like it won't project, your device won't project, or the network doesn't work, or you have audio and it's not working, then just switch to your keynote. So have your keynote slides as backup if you're going to go live demo. That's my recommendation. Okay? All right, so the proposal, sample proposal. Here I'm just going to show you what one would look like so you can kind of get an idea. So my sample proposal is I'm going to build a Shakespeare director app. So I'm a director of a Shakespearean play, and I'm going to have this nice iPad app to help me do that and help my actors. And so it's basically going to have a table for choosing a Shakespearean play, so you can pick a play, the one you're doing, and then it will let you lay out, you're the director, so you're going to lay out the blocking, which is where everyone stands on stage, on a little kind of graphical stage. So I'm going to have a draw rec there, I'm going to have gestures so I can move things around. It's also going to have a dialogue learning mode where it's going to show the dialogue line by line, so that actors can have their own iPad maybe while they're learning their lines, and they'll see their blocking and their lines right there at the same time. And they'll also be able to record the other people's lines, so it'll prompt them so they can sit there and learn their lines and all that. So you can see it's a pretty cool app, right? It's a pretty good idea. I'm basically explaining what it does in my proposal. I'm talking about limitations though, like I'm saying that my custom view is only going to be rectangles and circles, and I'll let them set colors. So the people are not going to be really great graphics. I'm just saying that I don't want to spend all my time doing that, so I'm just going to make my, when I lay out where everyone is on stage, it's just going to be blocks. See, so I'm kind of explaining in my proposal that I realize, because if I don't put that in here, then your TA is going to feed back and say, whoa, you're going to have this whole blocking thing? How complicated is that going to be? What are you going to allow? You see what I mean? So this heads that off by saying, okay, I understand that mostly I'm focusing on doing draw rect and gestures and things like that. That's what I'm trying to show you with this feature. But I'm saying here that I'm going to be able to let you take a photo of a person and put that in a rectangle so that when you're blocking, you can at least have pictures of the people, maybe in their nice costumes. And I'm saying other things here, you know, that sound, recording sound is going to be possible. Notice I mentioned that it's iPad only. Now, when I say iPad only there, that hurts breadth, okay? Because an app that works on both iPhone and iPad has more breadth, although it's pretty easy to make an app that just kind of works on both. But you still have to make sure the adaptations are working maybe, and that when it rotates in both times it does the right thing. So it's a little more work. So you just lost breadth. I lost breadth by saying iPad only. But I decided that this app just doesn't make sense without iPad. Although I could decide that maybe the blocking part is not on the iPhone version, just the dialogue warnings. Because I could imagine the actor standing here with just their iPhone learning their lines or whatever. So I could, if I needed the breadth, I could add that back in. Okay, so here's section 1. I'm explaining what I'm doing. Now here's section 2. Here's all the iOS API I'm going to use to implement that. I'm using table views, a custom table view cell, a UI view with draw rect, the camera, popovers. I'm using scroll view to zoom in and around on the blocking view. I'm using AV Foundation to do the recording of the sound. I'm using timers. I'm going to use this thing called core data, which is an object-oriented database to store my data in there. That would be a not covered in lecture feature because we're not covering that in lecture this quarter. I'm also going to make it so I can print out my blocking on a printer. That's also not covered in lecture. Okay, so there I'm doing substantial not covered in lecture features. I'm making it really clear what they are in my proposal, and I'm talking about all the other things I'm going to do. Okay? Does that help you understand what's going on there? The proposals? Okay, so you submit those proposals as soon as possible, but really no later than next Wednesday or next Tuesday, please, to your grading TA. Whoever graded your last assignment, just send it to your grading TA, and they have a lot of you to read, so they'll, as quickly as they can, get some feedback to you. If you don't give it to us by next Tuesday, you know, it's still going to be beneficial for you to send it to us. It's just that there can be less and less time for us to give you any feedback, and you're going to have to already have gotten started pretty soon by the end of next week. Let's say you probably really want to get started. So it's really your own thing. And again, though, it's not, you don't have to get it approved to do your, to start on your project, but unless you're the two-man team, you do. You don't have to get approved, but you really do want to get that TA feedback because you don't want to start off on a trajectory where the TAs are like, you're not likely to end up with much of a very good project here because there's not going to be enough breadth, or I don't understand what you're not covered in lecture feature is, or it's not a good enough one, or whatever. Now, the other thing to note is that proposal is completely non-binding, except for a little bit with a two-man team. But for everyone else, it's not really binding either way. So if what you turn in is completely different from your proposal, that's fine. Okay, we're not going to go back and say, hey, wait, you said in your proposal you're going to do that. Never, we will not say that. But vice versa, too. If we say in your proposal, oh, yeah, you know, doing core data for that, that sounds like a good not covered in lecture feature. And then you go to implement it, and you do such a trivial version of core data that it's like, it's not substantive enough, we still might ding you and say, hey, that was not a substantial not covered in lecture feature. In other words, your proposal is not graded. There's no part of the grade. We'll never look at it again. It's just to get you started on the right track. You are still responsible for delivering all the requirements that I talked about today in your final project, regardless of what's happening with your proposal. So it cuts both ways. We won't hold it against you, and you know, but you can't come back and say, oh, but you said that was okay. All right? Make sense? Okay. Last thing I want to talk about is collaboration. So people ask me, okay, but can I work with someone else not in this class on it? And the answer is absolutely you can. In fact, I strongly encourage that. In fact, last quarter, I had a thing where it was a requirement to go find somebody to work with outside of this class. But when I say that, be very careful. I mean non-coding help, okay? You can get someone to help you, like a marketing person or a sales person or somebody who is kind of a business development person or an idea man, okay, or idea woman who's going to give you an idea. That's fine for someone else to give you the idea, but you've got to totally be the coder and architect of the solution, okay, because you are in an iOS development class, so you've got to do the iOS development part of it, okay? Now, that other person who's helping you could also help you with things, maybe giving you assets. Maybe they could give you some images, or they might give you access to a database of something, or some network server that you can, all perfectly fair game. It's just they cannot help you with the actual coding of your app. And it can't be someone else in the class either. Okay, it's got to be someone outside of this class. Okay? So I do have two people here, two Stanford affiliates, who are going to get up and talk a little bit about what they're doing. And if you like what they're doing, then you can contact them, and maybe they would be your outside idea man or woman. And you could work with them to understand more what they want. Now, what they want might not be suitable exactly for a final project, because you know what the requirements are. You've seen them all today. They're specific academic requirements, and you've got to meet those. But by the same token, what you do, what their idea is, might help guide you towards putting together a lot of good features, and vice versa. If you work with these people and you find out, oh, this is really great and this is really interesting, maybe then after the class is over, you can say, okay, well, now let's work together and go do something really what we want to do based on the specs of what the requirements are. That make sense? So back to the learning about iOS itself. The next thing I'm going to talk about is the Unwind segue. Now, this is kind of a weird thing, because I taught you all this stuff about segues, and then the Unwind comes along and unwinds a little bit of your knowledge about it. The most important difference about an Unwind segue versus all those other segues that you know, the show segue and the popover segue, is that it does not create a new MVC. It's the only segue that does not, in the process of segueing, create a new instance of an MVC. Okay? It can only segue to an MVC that either directly or indirectly presented the current MVC. So the MVC that wants to unwind to another MVC has to have been presented directly or indirectly by that. So what's it good for? What was this unwind segue? What do we ever use it for? Well, it's really good for jumping back the stack of a navigation controller. Right, so you got a navigation controller, you got 6 cards, you know, things stacked on there, and you want to jump back to number 2 or all the way back to number 1. Okay? Well, in a navigation controller, each card down is considered to have been presented by the previous one. So it falls into this unwind segue thing where directly or indirectly you can go back up, unwind up. So that's one good thing about it. Another one is you have an MVC that's modally presented. Now again, I haven't talked really too much about modal presentation. I'm going to talk a little more about it today. But modal, I told you what modal is, though. Modal segue means take over the entire screen. Even a popover is basically modal. Because when a popover is up, you can't do anything except for what's in that popover. The only other thing you can do is dismiss the popover by clicking somewhere else. So that's kind of modal. It puts your app in a mode where you can only work in that one space. So a lot of time when a modal segue comes up on the screen, when it's done, it wants to communicate some results back to whoever presented it. Okay? So an unwind would be great for that. Because the only other alternative would be like delegation. And yes, you can have an MVC delegate back to another MVC, because we remember that delegation is our view talking back blind to our controller. And remember that an MVC can be part of the view of another MVC. So it's legal to use delegation. But unwind, it's just a lot easier. Okay, unwind provides a little pipe for the modal segue to unwind back to the one that presented it and communicate with it, okay, by segueing to it, basically. All right? So how does it work? Instead of control dragging from something to another MVC, okay, you can't really control drag to the presenter. It might be in weird places in your storyboard. It might not make sense. So instead, you control drag to this little button at the top of every view controller, which is called the exit icon. You see it there. It has the word exit. And when you control drag to that exit, okay, to make the segue, it's going to say, okay, where do you want to segue to? And instead of specifying a particular MVC, you specify a special IB action. Okay, so my IB action here, only one I have is go back. All right, that's the name of an IB action method somewhere in some MVC out there. Okay, now what's special about it is the argument of it is a UI storyboard segue. The same argument that's given to prepare for segue, okay, UI storyboard segue. That's what makes it special. So when you add an IB action method to any MVC and the argument of it is a UI storyboard segue, then when people control drag to their exit, they'll see it in this list. Okay, so it can be any MVC anywhere. Now, of course, if you try to unwind and you pick a method in an MVC and that no MVC presented you that implements that method, then the unwind segue is going to do nothing. Okay, because it's not going to be able to find a presenter who implements this method. Okay, so but let's say you do have a presenter. Let's say you're in a navigation controller and somebody who put you on screen has this method, go back. You see it takes a UI storyboard segue there. Then if I wire up my unwind segue to that, then I'm basically going to be segueing back to that presenter. Okay, so that's how you hook it up, basically. All right, now what happens once you get this hooked up? Oh yeah, so that has to be IB action and that has to be UI storyboard segue. Okay, otherwise Xcode will not be able to detect that possible unwind. Okay, so when you segue, it is a normal segue in that you get to prepare for segue, right? So the guy on the right there, he gets to implement prepare for segue. And when the unwind happens to his little exit button and it starts looking for that go back method somewhere in a presenter, he's going to get to prepare. So you just implement normal prepare for segue inside of that guy. And the presenter, okay, is going to get prepared. And then the presenter is also going to have this go back method called after it's prepared. Okay? So the presenter gets really prepared or gets information twice. It gets it once when it's prepared for segued, because it's the destination MVC, and it's going to get prepared. So now it's already here, so it's already pretty prepared, but maybe it gets prepared more. And then when the segue happens, go back will be called. And in the segue that's passed as the argument there, the presenter can find out who is segueing to me and what are they communicating to me. What do they want to communicate to me? In fact, they can talk to it, use this public API to get whatever information they want. So it basically creates a link. So you will be dismissed in the process. When you unwind, when the user clicks on whatever you control dragged to that exit button, after this happens, you're going to always get dismissed. Okay, so you will, if you're in a navigation controller, the navigation controller will pop back up to the presenter. If you're modal, you will go away. You'll stop taking over the whole screen. Okay, so you are going to unwind. That's why we kind of call it unwinding. You're wound up, and now you kind of get unwound. So yeah, so modal segues, navigation controllers, exactly the same mechanism. All right, so that's it for Unwind. It's as simple as that. You could possibly use Unwind in your assignment 4 if you want. I talk about it in the required task and the hints. It's not a required task. It's just a way you could do it, okay? And you can decide whether you want to use an Unwind or not. It would be a good experience for you to use an Unwind. Question?
Is the default back button in the navigation controller essentially doing that?
Yeah, so the question is the back button unwinding? And the answer is no. That back button is wired to a method in navigation controller called pop view controller. And it just pops up. So it doesn't get to do any of the unwind. It doesn't get to pre-prepared. You don't get you don't have to implement that IB action with it. So it's no. The answer is no. Okay, any other questions about that unwind? Okay, next topic, alerts and action sheets. Okay, so there are two kinds of pop up and ask the user something mechanisms in iOS. One is called an alert and one is called an action sheet. And they use actually exactly the same API. You set them up in exactly the same way. I'm going to show you how that works. What's the difference between the two? Okay, alerts, first of all, they pop in the middle of the screen. They're both modal. Okay, they're both basically modal view controllers. Okay, they're just kind of drawn in a certain way, but they're really just a modal view controller because they both take over the screen. But the alert takes over the screen and comes up right in the middle. Okay, and usually alert is going to ask you a question, ask the user a question where there's only kind of one or two answers like yes, no, or do this, cancel, or something like that. An alert also, by the way, can have a text field. So it could be like log in and you have to type your password in there, okay, or maybe even username and password. So it can collect text. An action sheet cannot collect text from user. Only the alert can do that. But if you had a question that had more than two answers to it, you're probably going to use an action sheet. Okay? So an action sheet, it presents on screen a little differently. It doesn't come up in the middle of the screen like an alert. It usually slides up from the bottom on an iPhone. On an iPad, we usually put it up in a popover. And I'm going to show you how we do that in a moment. An action sheet is sometimes referred to as a branching decision sheet. So where you're basically making a branching decision where the user wants to do one of 3 or 4 things and you're kind of picking which one you're going to do and you're going to head down that direction inside your app. Okay? So I think by example is the easiest way to kind of see the difference here. So I took our Cassini app that we wrote and I added a little button in the top that actually controls Cassini. Okay? It'll redeploy Cassini off to different places. Okay? Saturn, or you can send it off to Titan, or send it towards the sun or whatever. Okay, so I added that little redeploy button. You see it up in the right-hand corner there. It says redeploy. So part of my implementation of allowing Cassini to be redeployed, I used an action sheet and an alert. Okay, so here's the action sheet I used. When you click that redeploy button, it's going to put up an action sheet that says, where do you want to send Cassini to? I'm sure the Cassini guys have an app just like this. This is how Cassini is controlled. But our app only lets them send it to Saturn or Titan, moon of, is that a moon of Jupiter, I guess? Or they can go take a close-up of the sun, which is going to destroy Cassini, okay, because it's too hot there. Or they can cancel. So that's the action sheet that I invented. And then if you decide you want to go somewhere, then I put up an alert that says, oh, if you want to send Cassini to Titan, you need to log in, give your guidance system control password or something, okay? So this is my alert. Okay, so we're going to look at the code, how I did this action sheet and alert. Okay, so let's start with the action sheet. Now, the code for both looks incredibly similar. So what I'm teaching you here about an action sheet is almost going to be 100% applying to the alert. But basically, in either case, you create an instance of a UI alert controller. This is just a UI view controller. Okay, it's a subclass of UI view controller that gets presented modally, and that's basically it. Okay, alerts and action sheets are basically a subclass of UI view controller that gets presented modally. They just happen to draw in these particular ways. When you create the view controller, you're going to give the title. That you can see where the title redeploy Cassini appears there in my action sheet right at the top, and then a message which appears right below it in non-bold. That's actually probably using preferred fonts, so that's probably like a headline font and then the body font, I'm guessing. And then you specify the preferred style. So this is how you decide whether it's an action sheet or an alert. So here I'm doing action sheet, so I say UI alert controller style action sheet. So that means I'm making an action sheet. So that's it. I create my view controller. Now I need to add some items into there, like orbit Saturn, explore Titan, close-up of sun, cancel. How do I do that? Well, I do that by calling the method add action on the alert, on this view controller I just created. And the argument to that is a UI alert action, okay, which is another class that I'm going to create that really just kind of collects all the information about a particular action. So here's what UI alert action looks like. It's got a title. That's like orbit Saturn there, or explore Titan. That's the title. It's got a style. We'll talk about that in a second. And then it's got a handler. Okay, so here you're starting to see closures again in the iOS API. This handler is just a closure. Okay, the argument is going to be this action itself. So it's basically like sender. And inside this closure, you can do whatever you want to do when they click on that particular action, like orbit Saturn. So the code in there would probably go off and send Cassini instructions to go orbit Saturn. Okay? So let's look at an example of one of these. Let's look at orbit Saturn. The title is orbit Saturn. The style is default. Okay, we'll talk about some other styles in a second here, but default is just the default line, this blue colored text right there, like orbit Saturn, explore Titan. They're both that. And then the closure I'm going to put is just go into orbit around Saturn. And similarly, explore Titan would look exactly the same, also default style. And maybe Cassini's mission was, I think, to orbit Saturn or to go to Saturn. So maybe if you're going to switch it over to go into Titan, then you have to log in and do your guidance password. Otherwise, you can always send Cassini back to Saturn, I guess. Okay? So there's the example of the default actions. So let's look at the next one, that close-up of the sun. So the close-up of the sun is almost exactly the same, except for its style is not default. It's dot destructive. Okay? So dot destructive makes it show up in red. So anything that's going to really damage something, like delete this entry or something like that, you can make it dot destructive and it will show up in red. Okay? Otherwise, it's exactly the same as the other ones. And then the cancel one also has a special thing, dot cancel. All right? And you can see that cancel is kind of separated from the rest of them. It's down at the bottom. It's got a little extra space. That's pretty much the only difference between cancel, because you still get a closure there you get to execute when it's clicked on. Okay, so that's it. So alerts couldn't be any simpler to create. Okay, so that's how you create this view controller and configure it with its actions. Now, how do we put this thing on screen? How do we get this alert to actually slide up from the bottom? Well, it's just a UI view controller. We're going to present it modally. So there's a method in UI view controller called present view controller. I haven't really talked about it because we haven't talked about modal presentation. But all present view controller is, it presents a view controller on screen. And if it's a modal view controller like alerts are, it'll appear modally. Okay? It only has 3 arguments, which is the UI view controller to present, whether to animate it. So in the case of the action sheet, it slides up from the bottom. And then you also get a closure there, completion, which will get called. It's just a closure, takes no arguments, returns nothing. It will happen when it's done. So when that thing has been finally presented on screen and done its animation, boom, you get your completion called. You almost never do anything there. It really doesn't make a lot of sense. The thing's already up. It's doing its business. There's really no business for you as its presenter to be doing at that point, but you could. Okay? So that's it. So alerts are just UI view controllers. You just add actions to them, and then you present them. Now, what about this action sheet thing, though, on an iPad? Okay, so here's the same app in iPad, and I got that redeploy button up there on the right. Now look what happens when I do redeploy on the iPad. Same thing, but it shows up in a popover. Okay, doesn't slide up from the bottom. It wouldn't look very good if it slid up from the bottom. It would either be kind of silly narrow, or it would be so fat and wide it would look ridiculous. It makes much more sense to put it in a popover like that. Notice that the popover is different in one big way. No cancel button. Okay? And that's because you don't need a cancel button to cancel a popover. The popover is modal, and if you click anywhere else in your app, boom, it's going to cancel that popover. But if you have a cancel action, like this one does, its action still will be called, even in the popover cancel case. Okay? So that cancel thing is kind of still in play. It's just that you access it differently. Instead of hitting the cancel button like at the bottom of the iPhone version, you just click somewhere else and make the popover go away. Everyone understand that? All right, but how do we make this work? Because this is not quite enough information to present that popover. Okay? That popover needs one really important piece of information, which is who is popping me up. Because you see it has that little white triangle at the top that's pointing to redeploy. So nowhere here are we saying, oh, Mr. Popover, point to that redeploy button. Okay? So we need to say that. So that means when we're going to put this action, put any action sheet up, and it's going to happen on an iPad where it might be a popover, we need to get a hold of the popover presentation controller, the same one we got a hold of back when we were doing the popover in the previous app, the Psychologist app. Same popover presentation controller. We need to get it, and we just need to tell it, here's the button that's presenting you, so you can point to it. Okay? So we do that like this. We, first of all, just have to say that the alert's presentation style, its modal presentation style, is popover presentation style. If we don't tell it that, then it will never make a popover presentation controller. So we can't tell it anything because it won't exist. But once we say that this UI view controller's modal presentation style is a popover, now we can say, okay, well, give me the popover presentation controller, and the bar button item, which is that redeploy up there, is this. And so I point it to the redeploy bar button item, and now when it pops over, when it gets presented modally here, using a popover presentation, it will point to the redeploy button. Okay? The cool thing is, because of adaptive UIs, which we talked about back then, is that this code works exactly the same on iPhone. So if you put in those 3 lines to make the popover work, it won't affect the iPhone at all. Because the iPhone already adapts popovers to present over the whole screen, remember? And in fact, we had to go do some work in Psychologist to stop it from doing that adapting, so that it would show up in a little popover on the phone. But if you don't do any of that work, then by default, it shows just like this. Comes out, takes over the whole screen on the iPhone. So that's why setting the modal presentation style to popover still works on the iPhone because it adapts. Okay? Any question about that? So that's how you do an action sheet. You're going to do the same body of code you see right there for every action sheet you ever do. All right, now let's go talk about the alert. Okay? The only difference in creating the view controller is you say that its style is alert instead of action sheet. Otherwise, it's exactly the same. Okay? I have different text here, obviously, login required, and please enter your Cassini guidance system password instead of the other things. But otherwise, I'm just changing the style to be alert. I do the same thing with adding actions. So here I'm going to add the cancel button. Okay? I'm going to add the login button. Now, the interesting thing about the login button is when I log in, I want to get that text out of that text field to use as the password for my guidance system. Okay? So how am I going to do that? Okay? Well, first of all, we're going to ask, how do I put that text field there? Okay, I got to put that text field in my alert. So here's how we put a text field in an alert. A simple method, add text field with configuration handler. Okay? When you call that, it adds a text field to the alert, and it calls this closure so that you can configure the text field however you want. So here in my text field, I configured it to say guidance system password as the placeholder text there in the background. Remember in the smash tag, I had my search field say Twitter search query. Well, here I'm having this one say guidance system password in the background. And that's it. So I could do other things to, set the font or whatever I want of the text field there. And you can call add text field with configuration handler more than once, and then you'll get more than one text field. So you could have a login and a password field. Now, this is great. I've got the text field in there. When I click login inside the action for login, how do I get the text out of that text field? Okay. Well, that looks slightly more complicated than you might like. It looks like this. I'm going to let TF, which is going to be a pointer to that text field, equal alert.textfields, which is an array of any object, and it's optional array. Okay? So since it's an array, since it's an optional, I'm going to put a question mark there so that I can do this optional chaining and just fail. So TF, let TF, that could be nil. That could end up being nil. So that's the question mark. And then I'm going to say dot first. If you remember an array, the method dot first returns the first thing in the array if the array has anything in it. If not, it returns nil. So that's a great way to get something, the first thing out of an array and not have to check to see if anything's in the array, and it'll just return nil if there's nothing in the array. And then I've got to cast it to a text field because I told you it was an array of any object. Why is it an array of any object? don't ask. Historical reasons. It's the way Objective-C does things. It's not quite as expressive as Swift, but anyway, too bad. So you do this as question mark. So that also could return a nil. So there's 3 different things that could return nil. But if they don't, then I'm going to get a text field back. And if I get a text field back, then I can just take the text out of the text field and log in. Okay? Any questions about that? I know it's a little convoluted getting that text field out of there. All right? So that's it for alerts. You then do just present view controller, exactly the same as we did for action sheet or any other modal view. And how about an iPad? On iPad, it looks exactly the same. Takes over the whole screen. No need to do any popover business with alerts on iPad. Okay? So that's alerts and action sheets. Just UI view controllers that you're presenting modally. That's all they are. All right. Next topic, NS timer. So NS timer is a way to set up a timer that will call a method periodically. Okay? Now, it uses technology called run loop, which we're not going to talk about. So suffice it to say, for you in this course, you always have to use timers on the main queue. Okay? Because the main queue has a run loop. You can actually have run loops on other queues, other threads, but we're not going to talk about that. So main queue for you, NS timer, main queue. And so this timer, it's not really a real-time timer. It's like if you say go off every 2 seconds, it's not going to go off every 2.0000 seconds. And why is that? Because basically it's just putting things, it's kind of like it's putting things on the main queue, but not quite the same. The run loop helps process things that are happening, like interrupts or data that becomes available or whatever, and it can't run in real time because other things are on the main queue running, okay? Other blocks of code and stuff. So it can't quite guarantee it, but it has a high priority. So if as soon as the main queue becomes available after 2.0000 seconds have happened, it's going to call your method, okay? But it's not a real-time programming thing. I mentioned that for those of you who are like systems OS people and you're used to real-time APIs. This is not real-time, but it's really, really, really close to real-time. Okay? As long as you don't have any big things on your main queue that are blocking it up, which you shouldn't have anyway, right? Never block your main queue. Then your timer's pretty much going to run when you want. Okay? Now, this is not used for animation. We're going to talk all about animation later today and all of next week. And your assignment 5 is going to be all about animation. Timer is more like a complement to animation. Because when you're animating things, sometimes you do want to do something every second or every 2 seconds. You're really not going to be like doing something every 60th of a second. Okay? 60 frames per second animation. You'd never do that with a timer. It's not for that. Okay? It's just for things like maybe you have something where you have a score in a game and you update the score every second. Okay? So that you're not constantly changing it. Something like that. It's that kind of, it's used for that kind of thing. So the run loops, I said we're not going to talk about that. Okay, so how do you fire off one of these timers? How do you make it work? Well, you do it with a class function in NS timer. It's called a scheduled timer with time interval. Now be careful, there are 4 methods in NS timer that look very, very similar to this. Okay, but this is the one you want with this set of arguments. And the arguments are just, the first one is how many seconds between firings, how many seconds do you want to wait each time before you call this method again. The target is who you're going to send the message to. It can be any object. Okay? Remember, any object is not a struct or an enum, although things like string and number, those are, you're not going to subclass those anyway, but those are essentially any object because they're bridging over to NS string. But anyway, any object, okay, is any object, any class basically. And then selector is just the method to call when the timer goes off. User info is just like a cookie that you can hand off here, and then every time it fires, you'll be given that thing back. So it's just kind of a way of passing this argument off to your, so you don't have to keep it in like a class, or in a variable in your class or anything like that. You can just hand it off here. So it's like context for the timer. And then repeat is whether this thing just does it once or it keeps doing it every however many seconds. Okay? Is it a repeating timer or is it just a one-time do something in the future? And I showed you a way to do one-time thing in the future with dispatch last time. So this would be another way to do something once. Okay, so here's an example of calling it. So here I have a timer. It's going to go off every 2 seconds. It's going to send this message to myself called fire. Notice that that method can be any name you want, except for it has to have a colon there because it's going to have an argument. I told you that when you're specifying the name of a method, if it has an argument, you have to put a colon on the end. Okay? Otherwise, it thinks it's the method fire without an argument. And then user info, I'm passing nil. I don't really want any information. I could pass anything any object I wanted there. And then repeats equals true means it's going to fire every 2 seconds. It can fire in 2 seconds from now, and then 2 seconds after that, and 2 seconds after that. Repeat it forever until I invalidate it. Okay, so let's look now at the fire timer thing. It looks like this. You can basically do whatever you want in there. Okay, you're on the main queue, so you could do UI in here or whatever. If you pass some user info, you can get it out of the timer by saying the timer.userinfo. Now you've got that info. Okay, super simple to use these timers. If you want to stop a timer that's repeating, it's going off every 2 seconds, you want to stop it, you just send it the message invalidate. If you say timer.invalidate, it will stop. Okay. Another thing you can do to make your system perform better is put a tolerance in there. What a tolerance says is if I'm sending something to go off every 2 minutes, let's say, okay, when the 2 minutes is up, do I have to do it right away, or can I wait 5 or 10 seconds? If you let the system wait 5 or 10 seconds, it could pick an optimal time to call a more optimal time anyway, to call your timer. So my strong recommendation is try to give a tolerance. The tolerance is just a number of seconds that you're willing to wait after it would normally fire. Try to give a tolerance of like maybe 10% of your timer. So if you have a 2-second timer, give it a tolerance of 0.2 seconds or something like that. It'll let the system pick a more efficient time to run. Like for example, if your we didn't really explain how this works, but your device can kind of go to sleep a little bit when nothing's happening. Nothing's drawing on screen, no network activity. So it can kind of go into a little lower power state, and then it comes back awake every once in a while. Well, if you give it a little tolerance, it might be able to kind of go into that low power state and then come back up in that little window. But if you don't give it a tolerance, it might have to stay awake to make sure it hits that timer when you want it, you see? So the tolerance is exactly what it sounds like, a little bit of tolerance. Give the system a little better chance to manage your battery and all that. Okay? If you give it tolerance, it's not going to drift. In other words, if you give a tolerance, 2-minute timer, and you let it go an extra 10 seconds and it waits extra 8 seconds, the next one is not going to be 2 minutes after that 2 minutes and 8 seconds. It's still going to be 2 minutes after the first 2 minutes. You see what I'm saying? Within the tolerance. So it's going to stay on a schedule of every 2 minutes, even if it waits a little bit on 1 or 2 or 3, or it doesn't drift. Okay, that's timer. Okay, no question about that? It's a pretty cool little guy. All right, animation. So this is kind of intro to animation, this last 10 minutes of today's lecture. So let me talk a little bit about the kinds of animation that you can do in iOS. One is to animate the properties of a view, and that's what we're going to talk about today. So that's one kind of animation. Another one is animation of view controller transitions, like in a navigation controller, when you transition to the next card on the stack or something like that, or even a modal view controller like the UI alert or the action sheet that slides up from the bottom. Okay, that's another kind of animation, obviously. Okay, we're not going to talk about view controller transition animation in this class. It's not really that terribly difficult, but it's just like I got to pick things to talk about, and that one we're not going to talk about. Okay, but there is infrastructure for doing that. There's also something called core animation. Okay, core animation is this incredibly powerful animation engine that underlies all of this UI view animation that's going on. And core animation can animate arbitrary properties over time, and it knows how to juggle them and knows how to manage how to present them on screen over time. It's really super powerful. Unfortunately, I can't talk about that either. Okay, don't have time for that. But if you're going to do something serious animation inside views, and you're not going to use the next kind I'm going to talk about, core animation, know that it's there because you will eventually have to learn it. Okay. And the last one is called dynamic animation. That's physics-based animation. So that's giving views gravity and collision boundaries and other behaviors like friction and density, and then saying go, okay? And then they'll just behave, okay? So that's dynamic behavior based animation, and that's what we're going to talk about on Wednesday. And that's what your assignment 5 is mostly going to be about. Assignment 5 is going to do a little bit of view animation, which I'm going to talk about today, and then a lot of dynamic animation. Okay? And why do we have dynamic animation? Why do we have this physics thing? If you ever watch an iPhone app, you know, if you flip things up or let them drop down, like if you get your, don't do it now, but if you get your iPhones out and you go to the very front, you know, even if it's locked, and you pull down your notifications, you'll notice that it'll kind of hit the bottom and bounce a little. Okay? It won't just kind of, pull it down, it won't just go clunk, it goes boom. Okay? It kind of gives a soft landing. And that kind of animation turns out to be surprisingly important for the user experience. It makes the user feel a little more like, yeah, it's just kind of giving a constant warm, fuzzy feeling about what's going on, as opposed to feeling like a computer that is slamming things around, okay? So dynamic animation is really important for giving that really kind of homey feel to your UI, warm feel, okay? So that's why we spend a lecture on it next time. All right, so let's talk about animating view properties. Only certain properties can be animated at the UI view level. If you go down to core animation, you can do more, but at UI view level, you can really, the three that are most important to animate are the frame, that means moving your view around, the transform, that means rotating your view or scaling it in and out, and the opacity, the alpha, okay? So you can use this kind of animation to fade things out using the alpha, or to move around, although they won't move with this nice physics base, so I kind of recommend the dynamic animation for moving things, but it's really nice for alpha, okay, for fading things around, or if you're going to have rotating views, views that rotate. So how do we do this animation with these properties? It's done with class methods on UI view and closures, okay? So you have this class method. You basically say what kind of animation you want, how long you want it to take, things like that. And then you just provide a closure, and inside that closure, you change these properties, frame, transform, alpha. Just change them, okay? And then the system will animate those changes over time. Simple as that. So here's what the method looks like. It's called animate with duration. There's a few different kinds of it, but this is the basic one. You can see that it takes a duration. That's how long the animation is going to take. A delay is wait. Should I wait to start this animation? Options, we'll talk about those later. Then the block, okay, takes no arguments, returns no arguments there. That closure, that's where you're going to change those view properties. And it also has a completion closure. When it's done animating, the animation actually completed, it will call this, and it'll let you know whether the animation finished or whether it was interrupted by another animation that tried to change that same property. Okay, because you can have multiple animations going off at the same time. All right, so what does it look like to call this? Here's an example. So this is going to, 2 seconds from now, start fading my view out over 3 seconds. And when it's done fading out, it's going to remove it from a super view. Okay, that's what this one line of code does. Okay, it's got, I guess it's more than one line of code because you got the closures in there, but it's what it does. Okay, so you can see here that I say I want 3 seconds for it to take 3 seconds, but I want it to start in 2 seconds, so it's going to take 5 seconds total. Okay, it's not going to do anything for the first 2. And then in my block, I just changed my alpha, right, from 1, which it started out. I have an if that says only do this if I'm fully opaque. So I just set it to 0. That's all I have to do. And then in my completion block, if I finished, that's the if $0, that's the finished thing. If I finished, then I'm going to remove myself from SuperView. But if someone else animated alpha in between, then I'm not going to remove myself from SuperView, which makes sense, right? Because they probably changed the alpha to something non-zero. Okay? Now, a very important thing to understand about animation, all animation that's going on is, when you make changes, they happen immediately. The animation is just showing it to the user over time. Okay? So in this code, when I print myView.alpha equals myView.alpha, that is going to print 0. Because that closure changed it to 0, and it does it right away. Okay? Even though the user doesn't get to see it on screen for 5 seconds, that's irrelevant. The fact is, I just changed my alpha to 0. Okay? It's very important to understand, and it'll take some wrapping your head around until you really understand and work with it. But it's a little bit like multi-threaded programming to understand. But really, all animation is presenting it to the user over time. It's not changing it over time. Okay? All right, so that's it. So that's how view animation works. Here's all the options. There's billions of them here. You can change the curve. So curve ease in, ease out means that it starts slowly and then it speeds up to normal and then it slows back down again. So my fade, that's the way it worked. It would start fading out slowly and then normal speed, and then at the very end when it's fading out, fade out a little slower. Okay? You can also, I don't have time to show you all these things, but you can look at all these things. Begin from current state is an interesting one because I just told you that the change happens immediately. But if you issued another animation to change the alpha, and you had this begin with current state on, then that animation would pick up wherever any other animation is. So that other animation might be partway through doing the alpha, and then I do another animation with this begin from current state, and it's not going to start with it at 0, which is what alpha is now. It's going to pick up the partial. Okay? So that's one way where you can actually kind of over time get the value by issuing another animation. Remember, all these animations are happening like in another thread off the main queue. They're all happening out of time for you. Okay? When you said that last line of code, alpha immediately went to 0 and you're on your way. Your code is still going. The fact that things are happening on screen over time is kind of not relevant to you. It's relevant to your user though. Okay? Sometimes you want to change an entire view, and you can do that as well. So that's like, I'm going to give you an example here of a playing card. So if I had a playing card that has a back and a front, I might want to flip that card over. Okay, so I want to change everything in the view. I want to redraw the view basically, but I want it to flip over. I don't want it to just boop, change. I want it to have an animation where it flips over. So you can do flips over and curls up and dissolves. Okay, you can do all those. The way you do that is with a different UI view class method called transition with view. You just give it the view, the playing card view or whatever. You tell how long you want the animation to take, what kind of thing you want, like flipping or dissolving or whatever. You give it the animation. Inside that animation, you're changing your view, changing the attributes in your view. Like if you had your calculator and you wanted it to change from one graph to another, in here you would change the graph. Okay, you would change it so that draw rect, when it draws the next time, would draw something different. And then it would animate it, dissolve it, or whatever, and show the new version. So here, in this closure, you're changing anything you want about the view. Any attributes, any properties. So the next time it draws, it will draw differently, and then this animation will kind of interpolate between those two states, either doing a flip or a dissolve or whatever. So that's another kind of thing. Now this one, you're probably going to be doing in your homework. Okay, I think I asked you explicitly to do some sort of animation like this. Either this one or the last one, either one. So yeah, here's the playing card example. You can see in the closure, I'm just changing the card to be face up. And so the next time it draws, it's going to draw differently. Okay? And again, this happens immediately. That card is face up equals not card is face up. That happens instantly as soon as I call this method. Okay? It's just that over time on screen it will happen. But it happened immediately right there. If the next line I say if card is face up, it's going to be the changed value. Okay? These transition with views methods, animate with duration, they return immediately. They do what's in the closure and return immediately. Okay? If you're animating changes to the view hierarchy, like you're hiding views or removing them from super view, and that's all you're doing, and you want them to flip over and go away, then you can use this transition from view to view. Okay? Otherwise, it's exactly the same. It's just for things that change the view hierarchy. But it's just basically the same. So there's no closure there because the change you're making is changing the view hierarchy. You're not changing card is face up. You're actually changing whether the view is in the hierarchy anymore. Yeah?
I'm just wondering, so if you want to specify several of the options,
Yeah.
because it looks like they're not mutually exclusive somehow,
Yeah.
you specify that as an array or?
No, they are, that's a good question in this particular API. Ask me it on Piazza. I'll try and, I can't remember. Some APIs you specify as an array, some APIs different, depends. But most times Swift, it's an enum, so you are doing something like that or combining them. So ask me on Piazza. Okay, so that's it for today. On Friday, we have a great section, which is UI collection view. It's great because UI collection view is very similar to UI table view. You'll really understand UI table view if you go look at this UI collection view one. Monday's a holiday, and the next week I'm going to start on that physics-based animation. Thank you very much.
For more, please visit us at stanford.edu.